So today's content is series and parallel connection of SCR. So just revise the earlier content which we have studied in the previous lecture. In previous lecture we cover all the force commutation technique starting from class A, class B, class C up to the class E commutation techniques, and we are discuss about the dynamic characteristics of SCR. These two content we are covered in the previous lecture. So just overview the content of last lecture. In last lecture, we know about the difference between static characteristics and dynamic characteristics of SCR. So static characteristics, we are not getting the speed of the SCR which is capable to comes from blocking state to the conduction state, or we don't know the time interval which is required to transfer the SCR from blocking state to the conduction state. So that's why there is a need of dynamic characteristics. In dynamic characteristics, we explain through the dynamic characteristics how these SCR characteristics. आले का committee? So see this dynamic characteristics, we know how the SCR can comes from blocking state to the conduction state with the variation of time interval, right? So today's content is series and parallel connection of SCR. So what is meant by series connection and parallel connection, or what is the need of series connection and parallel connection of SCR in this power electronics? So if you want to increase the voltage rating capacity, in such case we are connecting number of SCRs in the series combination. For high voltage requirement, we are connecting number of SCRs in the series combination. While to increase the current rating or for high current application, we want to use the parallel connection of SCR. Means in simple way, SCRs are connected in series and parallel to extend the voltage and current rating. If you want to increase the voltage rating, then we are connecting the small rating of SCRs in the series combination, while if you want to increase the current rating, in such case we are connecting number of SCRs in the parallel connection. So for high voltage and high current application, if you want to achieve both, then in such case we are connecting the SCRs in series and parallel combinations. So single SCR is not capable to supply the enough high voltage. In such case, we are connecting the small rating of SCRs in the series connection to get the high voltage requirement. Right. Moving towards the first part, how the number of SCRs if you are connected in the series combination, then what is the effect of that series connection on different parameters, which parameters we are discussing in the previous lectures. That is nothing but the forward volting blocking stage, how it is work in that during the on state. All these parameters we are now discuss here. So in series connection, this figure represent that in that figure we are consider the three SCRs, and that three SCRs are connected in the series combination, right? And this figure is associated with the turn on process. These figures are associated with the turn on process. So we are first of all discuss about the forward blocking stage, means here all SCRs which are connected in the series combinations that are in the off state, वो ऑफ स्टेट में है. अभी सभी SCRs को भी अगर हमें ऑन करना है तो दैट इज अवर फर्स्ट स्टेज, एंड दिस फर्स्ट स्टेज इज द फॉरवर्ड ब्लॉकिंग स्टेज. I have considered some assumptions here according to the SCR. This is SCR number 1, SCR number 2 and SCR number 3 that are connected in the series combination, and some assumptions we are taken according to the rating of the SCRs which are connected in the series combination. So first assumption is consider that RD3 is greater than RD2 is greater than RD1. This is our first assumption, right? Second assumption that turn on time of second thyristor is greater as compared to the first one and thyristor number 3. T on time of 2 is greater than T on time of 1 is greater than T on time of 3. And third one is the Vt2 is greater than Vt1 greater than Vt3, and last assumptions are consider that T of time of third thyristor is greater than T of time of second and T of time of 1. By considering these assumptions, we are now discuss the turn-on process of series connection of SCR. We are connecting the number of SCRs in the series connection and we are going to on that SCR. So, to turn on the SCR, we are applying forward voltage across the string. Always according to our requirement, we are connecting the forward voltage across the string. So I have considered that the forward voltage is plus 1200 volt. Such voltage we are applying to that string. That's why this is the positive 1220 volt is connected to this point to the anode of the series, and your cathode of the series is become negative. So you know that during the forward blocking state, when all the SCRs are in the off states, voltage across the SCR is maximum, and whatever be the voltage we are applying from the input side, that are shared by the each SCR. So if these three SCRs of same ratings are connected in series and voltage is applied in the forward direction, then they do not share the voltage equally. If you are observing that in that figure, SCR number 1 will share the voltage 100 volt, while SCR number 2 is the 300 volt and SCR number 3 is the 800 volt. We are connecting the same rating of SCR in the series combination, but whatever be the voltage applied from the input side, according to that voltage, each SCR will share the different voltage, right? They do not share the voltage equally when they are in forward blocking state. So SCR which has minimum blocking state current will share the maximum voltage, and blocking state current we are defined in terms of voltage. Suppose we are considering that the blocking state current is nothing but voltage divided by current is equal to what? Current is equal to V into V divided by R. V is equal to I into R. So current is equal to V divided by R. Since here the blocking state resistance of thyristor number 3 is greater, blocking state resistance of thyristor number 3 is greater, that's why this SCR3 will share the minimum current as compared to this 2-1. And that's why voltage across the SCR3 is maximum as compared to this 2-1. So SCR number 1 will share the maximum voltage contributed from 1200 volt. So in figure, SCR number 3 will contribute the voltage 800 volt. So minimum blocking, the SCR which has minimum blocking current will share the maximum current. In another way, we are defined that the SCR which having the blocking state resistance is maximum, that SCR will share the maximum voltage. So after RD3, next blocking state resistance is the RD2. The SCR2 having the next share, next maximum blocking state resistance is there. That's why second SCR is also sharing the 300 volt. Blocking state resistance of SCR number 1 is the minimum as compared to this 2-1. That's why RD1 or the SCR1 whose blocking state resistance is RD1, it will share the 100 volt. So in this way, during the starting, that is during the forward blocking state, when we are applying the voltage in the forward direction, that voltage applied to the string, but the voltage according to the direction, they do not share the voltage equally when they are in forward blocking state. SCR which has minimum blocking current will share the maximum voltage, And this can be explained by taking the blocking state resistance of SCR. Also, the SCR which has maximum blocking state resistance will share maximum voltage, and in figure we are observing that SCR number 3 will share the maximum voltage as compared to the other two one. So this is our first stage when we are applying forward voltage to the string. No one SCR is comes into the on state, just we are applying the forward voltage, and according to that forward voltage distributions we are observing across the each SCR. Now the process is, second steps we are covered that what happened during the turn on process. We are observing the behavior of voltage distribution across this SCR during the turn on process. Now we are applying trigger pulse to the SCR. Whatever be the number of SCRs are connected, we are applying the trigger pulse to the SCR. This is the process when you are turn on the SCRs, string of SCRs. So when all SCRs are triggered simultaneously, but due to the difference in their turn on time, if you are observing this assumption that here we are getting that there is a difference in the turn on time. So since we are applying trigger pulse simultaneously to this string, but due to the difference in turn on time of SCR, voltage shared is not again same. So this figure, second figure represent here during the turn on process. Behavior of our voltage distribution across the SCR during the turn on process. So in that figure we are applying the trigger pulse to the each SCR which are connected in the series combination, but the voltage distribution across the SCR is again different because of the different turn on time of each SCR. So as per the assumption number 1, the SCR number 3 having the minimum turn on time as compared to this 2 1. The SCR number 3 having the minimum turn on time as compared to this 2 1. That's why this SCR 3 is comes into the on state first. This SCR number 3 is comes to the on state first, and hence minimum voltage is shared by this SCR, because during the on process when SCR is in the on state, voltage across the SCR is minimum while current is maximum. This is our condition. So due to the differences in turn on time of each SCR, the SCR3 which is having the minimum turn on time, that's why this SCR is comes into the on state first. After that, next turn on time of SCR number 1 is minimum as compared to the SCR number 2, and hence this SCR number 1 is comes into the on state after SCR number 3. SCR 3 के बाद हमारा कौन सा ऑन होने वाला है? SCR number 1, and since it is on, voltage shared across the SCR is minimum. As per the assumption, turn on time of SCR number 2 is very high as compared to this 2 1. So during this process, this 2 SCRs comes into the on state, but still we are applying the trigger pulse, and minimum voltage is shared by this 2 1. So remaining from 1 to 0 0 approximately, I think it is 19900, that all voltage is shared by the SCR number 2. Means this SCR will comes into the, it is not comes into the on state because the voltage across this SCR is maximum. Getting? So we are study about first stage, that is the forward blocking stage, in which we just apply the forward voltage across the string. Second figure represent that we are applying trigger pulse to the all SCRs, and simultaneously we are applying the trigger pulse to the all SCR, but due to the difference in turn on time, each SCR will share the unequal voltage distribution. The SCR which having the minimum turn on time, that will comes into the on state first and will share the minimum voltage. So from this figure number 2, it clear that SCR 1 and SCR 3 having the minimum voltage as compared to the SCR number 2, That's why these two comes into the on state, but SCR number 3 is not, SCR number 2 is not comes into the on state because out of this total voltage ये दोनों जल्दी से ऑन होने के कारण इसके अक्रॉस का वोल्टेज डिस्ट्रीब्यूशन कम हो गया है, and hence the remaining voltage which is applied from the input side nearly about the 1200 approximately equal 1200 voltage that is appear across the SCR number 2, and hence it is not comes into the on state because it will require more time to come into the on state. Going towards the third figure. This third figure represent that all SCRs are in the conduction state. All SCR are comes now in the conduction state. सभी के सभी SCR अभी on हो गए हैं, conducting state में आ गए. So when all SCR are comes in the conduction state, voltage across it is very small, and for given current it will be depend upon the VI characteristics of the SCR. So it is depending on the VI characteristics of the SCR. So as per this assumption number 3, as per this assumption number 3, VT2 is greater than VT1 greater than VT3. So voltage across the SCR number 2 is higher as compared to the remaining two. That's why in this third figure it indicates that voltage across the SCR3 is higher, that is 1.1 voltage, while the remaining two having the less voltage distribution. So we are observing that, from that we are concluding some point here. During the turn on process we are observing when number of SCRs are connected in the series combination of same rating के SCR हम यहाँ पे कनेक्शन में डाल रहे हैं, सीरीज कनेक्शन में. Even though if you are connecting the same rating of SCR in the series combination, during the turn on process we are observing that voltage distribution across the each SCR is different. Voltage distribution across the each SCR is different during the forward blocking state, during the turn on state, or even though when all SCR are in the conduction state. Now this is about the turn on process. यहाँ पे हमने turn on process observe की है. Now let us move to the turn off process of SCR. So again we are considering the same string, and whenever you want to turn off the SCR we are applying the reverse voltage. We are applying the reverse voltage across the string. So that's why we are reverse the voltage. Now this is the plus 1200 volt is applied to the cathode string, and negative terminal of that battery is connected to the anode string. So we are applying here the reverse voltage. So when we are applying reverse voltage, after applying the reverse voltage to commute the SCR, when we are applying the reverse voltage, reverse recovery current is start flowing. Reverse recovery current is start flowing. That just we are covered this topic in the dynamic characteristics of SCR. During the reverse process or during the turn off process of SCR, we are applying the reverse voltage across the string. Anode current becomes 0, but the SCR not goes into the off state because reverse recovery current and recombination time is again required, and after completing these two your SCR is goes into the off state. That is the discussion about the previous lecture in dynamic characteristics. So by considering this point, to commute the SCR, when we are applying the reverse voltage, the reverse recovery current start flowing and instantly no SCR be reversed. जल्द से जल्द कोई भी SCR आपका recovered नहीं हो रहा है, no one SCR can be recovered. As such, voltage across all SCR is same. Voltage across all SCR is same as like as this last figure. Is last figure that indicate that all SCR are in the conduction state. Voltage distribution if you are observing 1 volt, 1.1 and 0.9 volt. Same figure we are considering here. we are considering the same figure, only we are applying the reverse voltage. But since after applying the reverse voltage, reverse recovery current start flowing through the circuit, but no one SCR can goes into the off state instantly, and hence the voltage distribution across the each SCR is a low voltage, and hence we are showing the 1 volt, 1.1 volt and 0.9 volt. Means here your SCRs are not in the off state. यहाँ पे सभी के सभी SCR आपके अभी भी ऑफ नहीं हो पा रहे, आपने टर्न ऑफ प्रोसेस स्टार्ट कर दिए, बट योर ACRs आर नॉट गोज इनटू द ऑफ स्टेट बिकॉज वी आर अप्लाइंग द रिवर्स वोल्टेज, but because of the reverse recovery current start flowing through the circuit, according to the no one SCR can goes into the off state instantly, and hence the voltage distribution across the each SCR is small. Next figure represent that one SCR is recovered. This figure represents that one SCR is recovered. So out of these three, as per the assumption, turn off time of SCR number 1 is smallest as compared to these two one. SCR2 and SCR3 having the maximum turn off time as compared to the turn off time of SCR number 1, and hence SCR1 is comes into the off state first. That's why SCR1 is comes into the off state first, and if the SCR is goes into the off state, maximum voltage is shared by the SCR. So that's why from among 1 to 0 volt, that approximately same voltage is shared by the SCR number 1 and it goes into the off state. While turn off time of SCR number 1, SCR number 2 and SCR number 3 is greater. So that's why voltage distribution, these two are not goes into the off state instantly. Only one SCR is recovered here, only one SCR is comes into the off state. Remaining two are still into the on state, and voltage distribution across the each SCR is same as the previous one because they are in the on state. Figure 3 represent, third figure represent that all SCRs are now recovered. All SCRs are goes into the off state. And when all SCR is turned off, sharing of voltage is again depending upon the VI characteristics of SCR. In reverse direction, if VI characteristics is same as similar with the forward direction, then voltage distribution will shown in this figure, and SCR number 3 will share the maximum voltage as compared to the remaining two ones. So from above discussion, here we are observing that when all the SCRs are recovered or when all the SCRs are in the off state, and voltage distribution across this SCR is depending upon the VI characteristics of SCR. If we are assuming that the VI characteristics during the forward and reverse is same, so according to that assumption, we are observing during the forward case also when all the SCRs are in the off state, voltage distribution is unequal. According to the dynamic resistance, it will share the voltage. The resistance, the SCR which having the maximum dynamic state resistance, which will share the maximum voltage. So as per these assumptions and fundamentals, during the reverse process also, when all the SCRs are recovered and goes into the off state, according to the dynamic state resistance or VI characteristics, SCR number 3 will share the maximum voltage as compared to the remaining two. So from above discussion during turn off state as well as during the turn on process, in both the discussion we are observing that when number of SCRs are connected in the series combination during the turn on as well as during the turn on process, we are observing that voltage distribution is not same. Voltage distribution is not same during static condition as well as during the dynamic condition. And you know that the fundamental of series as well as if you are connecting the same rating of SCR and due to their different turn on time and turn off time, if they are trigger at wrong instant, or it will comes into the on state late or comes into the off state late, then it is not a favorable condition in the series connection, because we are connecting the number of SCR to increase the high rating, to increase the high voltage requirement, to supply the high voltage requirement. We are connecting the number of SCRs in the series combination. So this, to equalize the voltage distribution during the both stage, we want to use the equalizing circuit which are connected across the SCR. So to minimize this voltage distribution, or to equalize this voltage distribution across the each SCR, we are using the we are using some equalizing circuit, and that equalizing circuit will equalize that voltage distribution across the each SCR, so that all SCR can be triggered simultaneously, all the SCRs can be a turn off simultaneously. So by considering this requirement, we are develop the equalizing circuit arrangement. So today we are only covered the series connection of SCR and observe the turn on process and turn off process of SCR during the series connection. In next lecture we are observing how we are connecting the number of series connection equalizing circuit,